Hello friends, myself R.D. Mahajan presenting my video on Z transform, properties of Z transform. The first property, if Z transform of f of n is equal to f bar of z, then Z transform of that function f of n multiplied by some a raised to n is obtained by replacing z by a, that is f bar of z by a. First example, find Z transform of 1 by 4 raised to n into sine of n pi by 2. Therefore, here f of n is sine n pi by 2 and it is multiplied by a raised to n type of term. And therefore, we know that Z transform of sine of n pi by 2, standard result, Z sine omega, here omega is pi by 2, therefore sine of pi by 2 divided by z square minus 2z cos pi by 2 and plus 1. Standard values for sin pi by 2 and cos pi by 2. Sin pi by 2 is 1, therefore it is z in the numerator, and cos pi by 2 is 0, therefore it is z square plus 1, and we call this as f bar of z sec. Then, applying this property, Z transform of 1 by 4 raised to n into sine of n pi by 2 is equal to, as per this property, it is f bar of z by a. A is here 1 by 4, therefore divided by 1 by 4. Nothing but f bar of 1 upon 1 by 4, it becomes 4 into z. Means replacing z by 4z throughout this result, and therefore it becomes 4z divided by 4z whole square plus 1 as a required result. Second example, find Z transform of 2 raised to n into sine of 2n plus 3 for the condition n greater than or equals to 0. Here f of n is sine of 2n plus 3 and that is multiplied by 2 raised to n, means we can apply this property. First of all, we have to expand that sine of 2n plus 3 as sine a cos b plus cos a sine b. Therefore, sine of 2n into cos 3 plus cos a means cos of 2n into sine b sine of 3. Then we find Z transform on both sides, and therefore Z transform of sine of 2n plus 3 means Z transform of right hand side term. It is cos 3 into sine 2n plus sine 3 into cos of 2n. It is equals to constant term we take outside and taking Z transform of the remaining term. Therefore, cos 3 constant term we take outside, Z transform of sine of 2n plus sine 3 constant term and Z transform of cos of 2n. Then applying standard results, we get cos 3 Z transform of sine omega n is Z sine omega. Omega is here 2, therefore Z sine 2 divided by Z square plus 2Z cos of omega cos 2 plus 1 plus sine 3 as it is, no change. and Z transform of cos of omega n. Standard result, Z into Z minus cos omega, cos of 2, omega is here 2, and divided by Z square minus 2Z cos of omega means cos 2 and plus 1. Taking LCM as Z square minus 2Z cos 2 and plus 1, and adding numerator terms, we get sin 2 cos 3, sin 2 into cos of 3 into Z plus sin 3 multiplied by Z into Z, it becomes Z square minus Z cos 2. And whatever this result we call it as f bar of Z, say. And then applying this property, Z transform of this term is nothing but f bar of Z by A. A is here 2. Z transform of 2 raised to n into sine of 2n plus 3. As per this property, it is f bar of Z divided by A, and A is here 2. And to obtain this value, we replace Z by 2 throughout this expression on the right hand side. It is equals to sin 2 cos 3 as it is, no change. Replace Z by 2 plus sin 3 as it is into Z square means Z by 2 whole square minus Z, again replace it by Z by 2 cos 2 and whole divided by Z square, it is replaced by Z by 2 square minus 2 times Z by 2 cos 2 plus 1. We keep this step as it is. No further simplification is possible, and therefore whatever this, it is the required value of Z transform. Therefore in this video I have discussed two simple problems based on this property. Once again I will repeat that property. If Z transform of f of n is f bar of Z, then it's Z transform of f of n multiplied by some a raised to n is obtained by replacing Z by A. Therefore it is equals to f bar of Z by A. In my next video I will discuss the second property of Z transform. Therefore if you like my video, please share it, as well as subscribe to my channel, and to receive the notification for my all new videos, you have to press the bell icon. Thank you. Thanks for watching.